So adding fractions, this confuses a lot of students because they do the following mistakes. So they might see a question like, helps if I get the pen. They might see a question like 1/2 plus 2/3, and then they will add along the top, so they'll write 3 5s. You cannot do that. It is wrong. Utterly wrong. So let's do it the right way. This you take in stages. First job, you times this number and this number together, and we create this setup. 2 times 3 is 6, and we put 6's here. Now what you do is something called cross multiplying, which means you take this number here and you times it by this number here, and your answer ends up over here. So 1 times 3 is 3. You know what, I'll colour this in green so you can see the movement. Now we cross multiply this one. 2 times 2 is 4, and your answer ends up over there. Now we've created 1/2 plus 2/3 equals, i.e. is the same as 3/6 plus 4/6. We then put another equal sign, and at this point, and at only this point, are you allowed to add the two top numbers. So you end up with 3 plus 4 equals 7. These bottom numbers never get added. So that is a 6. You do. That is the correct answer, 7/6. Although some students, and it is technically right, will say, no, you can't do that. This is a top-heavy fraction, which means that the top number, the numerator, is bigger than the denominator. Okay, fine. The quickest way of dealing with it is this. This is a divide sign. 7 divided by 6, i.e. how many 6's are in 7? 1. What's remainder? Remainder 1. We put a line here. We put our remainder in here. That's 1. And we just put the number 6, just bung it in there. That's the quickest way out of a problem like this. You could, if you wished, convert this top-heavy fraction to a decimal. So you could have said equals and then do 7 divided by 6, which would have ended up with a very odd number. It will be, if memory serves, 1 point, no, it won't be 1.6, it will be 1.16 recurring. Let me just double check that I'm sure that's right. So that will be 7 divided by 6, 1, carry the thing, carry the 1, that's another 1 there, the 4 there, and 6 6s are 36. Yeah, I was right, it's 1.6 recurring. How do I know that? Don't ask. Well, not yet anyway, because that is a whole new skill of memorizing fractions and their decimal equivalents. That's why I knew it was 1.16, and the 6 is recurring, hence that dot, which for those who don't know, that dot there means the number underneath repeats itself forever and ever and ever. And that is how you add fractions. One final thing is, if your fraction was not 7/6, let us just imagine for a moment that the answer was, let's say, I don't know, 5/6. Well, you didn't need to do the next step of converting it to a decimal or a mixed number. You just leave it like that. Right, that's all I need to do on this. So let's now talk about subtracting fractions. We've added fractions, let's subtract them. The rules are similar to adding fractions, except at the end you take away rather than add. So once again, you cannot do this. That is utterly wrong. So let's do it properly. First job, put 2 lines there. We put a takeaway sign. Right, now let's multiply these two bottom numbers. 10 times 7 is 70. Now we do the cross multiply, i.e. 9 times 7, we put our answer in there. 9 sevens are 63. Then we do this side. 3 times 10 is 30. So the 30 will land in there. And then we keep going. And we put an equal sign there. 63 minus 30 is 33. The 70s never change. So it's 33 over 70. If you can simplify this, you must, and that, by the way, is the same for the adding. If your answer at the adding can be simplified, you must simplify it. Can I simplify this? No, I can't, so I must leave it like that. That's it. That is subtracting fractions.